file processing. Learning objectives. In this chapter, the user would learn the following in detail: concepts of files, file opening in various modes and closing of a file, reading from a file, writing onto a file. What are files? Many real-world problems handle large volumes of data, and in such situations, external storage devices like the floppy disk and the hard disks are used. Data is stored in these devices using the concept of files. A file is a collection of related data stored on a particular area of the disk. File names. Every disk file has a name, and one must use file names when dealing with disk files. File names are stored as strings just like other text data. The rules as to what is acceptable for file names and what is not differ from one operating system to another. Opening a file. The process of creating a stream linked to a disk file is called opening the file. When one opens a file, it becomes available for reading, meaning that the data is input from the file to the program. Writing, meaning that data from the program is saved in the file or both. After working with the file, close the file. To open a file, use the fopen library function. The prototype of fopen, open close bracket, is located in stdio.h and it reads as follows. This prototype tells the programmer that fopen, open close bracket, returns a pointer to type file, which is a structure declared in stdio.h. The members of the file structure are used by the program in the various file access operations. There is no need to be concerned about them. However, for each file that has to be opened, one must declare a pointer to type file. The fopen, that function, creates an instance of the file structure and returns a pointer to that structure. A programmer uses this pointer in all subsequent operations in the file. If fopen fails, it returns null. The argument file name is the name of the file to be opened. As noted earlier, file name can and should contain a path specification. The file name argument can be a literal string enclosed in double quotation marks or a pointer to a string variable. The argument mode specifies the mode in which to open the file. In this context, mode controls whether the file is binary or text and whether it is for reading, writing or both. The default file mode is text. Values of mode for the fopen function. File into ptr file. ptr file is equal to fopen, open bracket, open quote, file name, close quote, comma, open quote, mode, close quote, close bracket. Different steps to open file. Step 1. Declaring file pointer. Firstly, one needs pointer variable which can point to file. The syntax for declaring the file pointer is: Step 2. Opening file hello.txt. fp is equal to fopen, open bracket, open quote, mode, close quote, close bracket, semicolon. Closing the file. fclose function is file handling. When a programmer opens a file in read or write mode, then he performs appropriate operations on file, and when file is no longer needed, then he closes the file. File close will flush out all the entries from buffer. Important: after performing all operations, file is no longer needed. File is closed using fclose function. All information associated with the file is flushed out of buffered. Closing file will prevent misuse of file. Writing and reading file data. A program that uses a disk file can write data to a file, read data from a file, or a combination of the two. One can write data to a disk file in 3 types. First way, one can use formatted output to save formatted data to a file. one should use formatted output only with the text mode files. The primary use of formatted output is to create files containing text and numeric data to be ready by other programs such as spreadsheets or databases. Second way, one can use character output to save single characters or lines of characters to a file. Although technically it's possible to use character output with binary mode files, it can be tricky. One can write data to a disk file in three types. One should restrict character mode output to text files. The main use of character output is to save text, but not numeric data, in a form that can be read by C as well as other programs such as word processors. Third way, one can use direct output to save the contents of a section of memory directly to a disk file. This method is for binary files only. Direct output is the best way to save data for later use by a C program. When one wants to read data from a file, he has the same three options: formatted input, character input, or direct input. The type of input one would use in a particular case depends almost entirely on the nature of the file being read. The data will be read in the same mode that it was saved in, but this is not a requirement. Formatted file input and output. Formatted file input-output deals with text and numeric data that is formatted in a specific way. It is directly analogous to formatted keyboard input and screen output done with the printf and scanf functions. Formatted file output. Formatted file output is done with the library function fprintf open close bracket. The prototype of fprintf open close bracket is in the header file stdio.h and it reads as follows: int fprintf open bracket file in caps file asterisk fp comma char asterisk frmt comma close bracket semicolon. The first argument is a pointer to type file. To write data to a particular disk file, pass the pointer that was returned when the file was opened with fopen. Formatted file output. The second argument is the format string. The format string used by fprintf follows exactly the same rules as printf. In other words, in addition to the file pointer and the format string arguments, fprintf takes 0, 1 or more additional arguments. This is just like printf. These arguments are the names of the variables to be output to that specified stream. Remember, fprintf works just like printf, except that it sends its output to the stream specified in the argument list. Formatted file input. For formatted file input, use the fscan library function, which is used like scanf, except that input comes from a specified stream instead of from stdin. The prototype for fscanf is int fscanf open bracket file asterisk fp comma const space char asterisk fmt close bracket semicolon. The argument fp is the pointer to type file returned by fopen, and the fmt is a pointer to the format string that specifies how fscanf is to read input. The compositions of the format string are the same as for scan open close bracket. Finally, the ellipses open bracket and so on close bracket indicate one or more additional arguments, the addresses of the variables where fscanf is to assign the input. Character input and output. When used with disk files, the term character input and output refers to single characters as well as lines of characters. The line is a sequence of 0 or more characters terminated by the new line character. Use character input and output with text mode files. Character input. There are 3 character input functions, getC and fgetC for single characters and fgets for lines. The function getC and fgetC are identical and can be used interchangeably. They input a single character from the specified stream. Here is the prototype of getC, which is in stdio.h. intgetc, open bracket, file asterisk fp, close bracket, semicolon. The argument fp is the pointer returned by fopen when the file is opened. The function returns the character that was input or EOF on error. getC was used in earlier programs to input a character from the keyboard. This is another example of the flexibility of C streams. The same function can be used for keyboard or file input. The getC function program. The fgets function. To read a line of characters from a file, use the fgets library function. The prototype is char asterisk fgets, open bracket, char asterisk str, int n, file asterisk fp, close bracket, semicolon. The argument str is a pointer to a buffer in which the input is to be stored. N is the maximum number of characters to be input, and fp is the pointer to type file that was returned by fopen when the file was opened. When called, fgets reads characters from fp into memory starting at the location pointer to by str. Characters are read until a new line is encountered or until n-1 characters have been read, whichever occurs first. By setting n equal to the number of bytes allocated for the buffer, str, one prevents input from overwriting memory beyond allocated space. The n-1 is to allow space for the terminating \0 that fgets adds to the end of the string. If successful, fgets returns str. File processing. The putc function. The library function putc writes a single character to a specified stream. Its prototype in stdio.h is as shown. The argument ch is the character to output. As with other character functions, it is formally called a type int, but only the lower order byte is used. The argument fp is the pointer associated with the file, the pointer returned by fopen when the file was opened. The function putc returns the character just written if successful or EOF if an error occurs. The symbolic constant EOF is defined in stdio.h and it has the value -1. Because no real character has that numeric value, EOF can be used as an error indicator with text mode files only. The fputs function. To write a line of characters to a stream, use the library function fputs. This function works just like puts. The only difference is that with fputs, one can specify the output stream. Also, fputs doesn't add a new line to the end of the string. One must explicitly include it. The argument str is a pointer to the null terminated string to be written, and fp is the pointer to type file returned by fopen when the file was opened. The string pointed to by str is written to the file, minus its terminating \0. The function fputs returns a non-negative value if successful or EOF on error. Direct file input and output. The direct file input-output most often when one has to save data to be read later by the same or a different C program. Direct input-output is used only with binary mode files. With direct output, blocks of data are written from memory to disk. Direct input reverses the process. A block of data is read from a disk file into memory. For example, a single direct output function call can write an entire array of type double to disk, and a single direct input function call can read the entire array from disk back into memory. The direct input-output functions are called fread and fwrite. The fwrite function. The fwrite library function writes a block of data from memory to a binary mode file. Its prototype in stdio.h is int fwrite open bracket void asterisk but f, comma int size, comma int count, comma file in caps, asterisk fp close bracket semicolon. The argument buff is a pointer to the region of memory holding the data to be written to the file. The pointer type is void. It can be a pointer to anything. The argument size specifies the size in bytes of the individual data items, and count specifies the number of items to be written. The argument fp is, of course, the pointer to type file returned by fopen when the file was opened. The fwrite function returns the number of items written on success. If the value returned is less than count, it means that an error has occurred. The fwrite function program. The fread function. The fread library function reads a block of data from a binary mode file into memory. Its prototype in stdio.h is int fread open bracket void asterisk buf, comma int size, int count, comma file in caps, asterisk fp close bracket semicolon. The argument buff is a pointer to the region of memory that receives the data read from the file. As with fwrite, the pointer type is void. The argument size specifies the size in bytes of the individual data items being read, and count specifies the number of items to be read. Note how these arguments parallel the arguments used by the fwrite. Again, the size of operator is typically used to provide the size argument. The argument fp is the pointer to type file that was returned by fopen when the file was opened. The fread function returns the number of items read. This can be less than count if end of file was reached or an error occurred. The fread function program. File buffering, closing and flushing files. When one has done with using a file, one should close it using the fclose function. The fclose prototype is int fclose open bracket file asterisk fp close bracket semicolon. The argument fp is the file pointer associated with the stream. Fclose returns on successor or -1 on error. When one closes a file, the file's buffer is flushed, that is, written to the file. One can close all open streams except the standard ones. stdin, stdout, stdprn, stderr, and stdaux, close bracket, by using the fclose all function. Its prototype is as shown: int fclose all open bracket void close bracket semicolon. This function also flushes any stream buffers and returns the number of streams closed. When a program terminates either by reaching the end of main or by executing the exit function, all streams are automatically flushed and closed. However, it is a good idea to close streams explicitly, particularly those linked to disk files. The ftell and rewind functions. To set the position indicator to the beginning of the file, use the library function rewind. Its prototype is stdio.h is void space rewind open bracket file in caps asterisk fp close bracket semicolon. The argument fp is the file pointer associated with the stream. After rewind is called, the file's position indicator is set to the beginning of the file, byte 0. The rewind is used to read some data from the beginning of the file again without closing and reopening the file. Text file, file.txt, which has the following content. To determine the value of a file's position indicator, use ftell. This function's prototype is located in stdio.h and reads as follows. Long ftell open bracket file in caps asterisk fp close bracket semicolon. The argument fp is the file pointer returned by fopen when the file was opened. The function ftell returns a type long that gives the current file position in bytes from the start of the file. The first byte is at position 0. If an error occurs, ftell returns -1 of type long. Text file, file.txt, which has the following content. Compile and run program. This will produce the following result. fseek function. More precise control over a stream's position indicator is possible by the fseek library function. By using fseek, one can set the position indicator anywhere in the file. The function prototype in stdio.h is as follows. int fseek open bracket file asterisk fp comma long offset comma int origin close bracket semicolon. The argument fp is the file pointer associated with the file. The distance that the position indicator is to be moved is given by its offset in bytes. The argument origin specifies the move's relative starting point. There can be 3 values for origin, with symbolic constants defined in io.h. fseek function program. Compile and run the above program. This will create a file, file.txt, with the following content. Initially, program creates file and writes. This is a sample program, but later we reset the write pointer at 7th position from the beginning and use puts open close bracket statement which overwrite the file with the following content. foff function. With a binary mode stream, one can't detect the end of file by looking for -1 because a byte of data from a binary stream could have that value, which would result in a premature end of input. Instead, the library can be used, function feoff, which can be used for both binary and text mode files as shown. The argument fp is the file pointer returned by fopen when the file was opened. The function feoff returns 0 if the end of the file fp hasn't been reached, or a non-zero value if end of file has been reached. If a call to feo detects end of file, no further read operations are permitted until a rewind has been done. fseek is called or the file is closed and reopened. Text file, file.txt, which has the following content. This file will be used as an input for our example program. Let us compile and run the above program. This will produce the following result. Conclusion. In this chapter, we have covered the following aspects of file processing, concepts of files, file opening in various modes and closing of a file, reading from a file, writing onto a file.